Why was Maurizio Gucci killed by his wife? And even though there was a good movie about it recently, what was the part of the movie that was left out? Who was Charles Whitman? And what did changes in his brain have to do with him becoming a school shooter? And what does any of this have to do with Friedrich Nietzsche, or guessing which sex offender is going to re-offend, or the notion of culpability? Where does the study of the brain overlap with how we think about our legal system? Welcome to Inner Cosmos with me, David Eagleman. I'm a neuroscientist and an author at Stanford University, and I've spent my whole career studying the intersection between how the brain works and how we experience life. In the last episode, we talked about all the ways in which your unconscious brain drives the show of what's happening in your life. We feel like we make free decisions, that we have free will, but it turns out that your actions, your beliefs, who you are, these are all driven by mechanisms well below the access level of your conscious mind. So given that foundation, we're now going to explore what this means for us on a societal level. Today, we're going to talk about the intersection of brain science, which is playing out in labs all over the world, and the legal system, which plays out on streets and courthouses all around the world. These are usually thought of as separate issues, but in fact, they are inseparable. What happens when someone commits a crime, and it might have something to do with a disease or defect in their brain? Do we punish them differently? We can't just let them off the hook, right? Because the job of the legal system is to keep everyone safe. So what is the right thing to do here? So today I'm going to give you the argument why we can't keep pretending like everyone is exactly the same on the inside, and that we all act from our own free will, because modern neuroscience suggests these are bad assumptions. So let's dive into the inner cosmos. When you look at neuroscience labs on any campus all over the planet, you find entire labs devoted to studying the brain at the level of the human genome, or studying the incredibly precise orchestra of molecules that dance around the genome, or other labs that study the cascades of signals that pervade a cell and go all the way to the membranes and can get excreted and so on. Or you can devote an entire lab to understanding the behavior of individual neurons, which are like their own little animals with their own personalities. Or you can study giant networks of neurons and how information flows in those networks and how those are changed by chemicals, by what you eat, your environment, your society, your religion, your culture. All these are different aspects of neuroscience. Now, my personal interest has always been in studying all these levels and trying to understand how they map onto our behavior, our perception, our reality. As I worked to demonstrate in the last episode, you are built out of this alien computational material. You are not separate from your brain. So what I want to do now is give you 3 examples to illustrate this point. Some of you will be familiar with the story of a young man who had a terrible accident that taught the world a lot about how your brain maps onto who you are. This young man was named Phineas Gage, and in 1848, he was working with a crew on a railroad near Cavendish, Vermont. And the way the land was cleared to build the railroad was by a series of explosions. So the way this would work is one guy would dig small holes, and then a second guy would fill those holes with gunpowder, and another guy would put sand on top of the gunpowder, and then Phineas Gage would go around and tamp down the sand on top with a big metal rod called a tamping rod. So one day, the guy ahead of him forgot to put the sand on top of the gunpowder in one of these holes. And Phineas didn't notice that. And so when he pounded the tamping rod into the hole, the metal rod hit a rock and caused a spark, and the gunpowder exploded. And this metal tamping rod, which was about the width of a dry erase marker and almost 4 feet long, this exploded into his head and straight through it. It went below his chin and it burst out the top of his skull. And this metal rod clattered to the ground 80 feet away. Now, this became a very famous medical case because he didn't die. And in fact, he didn't even lose consciousness. The first doctor to arrive on the scene about 30 minutes later wasn't even quite sure that he believed what everyone was saying had just happened. But then Phineas got up and vomited and, quote, a half a teacup full of brain fell out on the floor. But it became a really, really famous medical case because Gage's personality changed entirely. His friends said he, quote, is no longer Gage. He went from a nice young man to someone who cussed and gambled and slept with sex workers. And this was an early case that started opening the door to an understanding of something massively important. And that is, when your biology changes, you change. Now, I want to take as a second example a clean-cut young man named Charles Whitman. On a hot day in 1966, Whitman climbed to the top of the tower on UT Austin's campus and began to shoot people at random. He shot at pedestrians. He shot at the people who came to help them. He shot at the ambulance drivers that came to help them. In total, he murdered 14 people that day and wounded 31. But there was a mystery about Whitman, and that is, there was nothing in particular about him that would have presaged this kind of horrific act. He had been an Eagle Scout. He'd been honorably discharged from the Marines. He'd come back to UT Austin to be in the architectural engineering program. He was married. He was a good student with a high IQ. He just wasn't the type of person that you would predict for a murdering spree like this. But about a year before the tower shooting, he began to feel changes inside. He wrote about this extensively in his diary. He explained that he was not feeling like himself. He went to see a psychiatrist to express that he was feeling more and more uncontrollable anger. But this was in the 1960s. There were no imaging technologies available. There was little that could be done clinically. So as it turns out, the night before the tower shooting, he murdered his wife and his mother. And then he sat down at his typewriter and he wrote a suicide note. And here's part of it. Quote, I do not quite understand what it is that compels me to type this letter. I do not really understand myself these days. I'm supposed to be an average, reasonable, and intelligent young man. However, lately, I cannot recall when it started, I have been a victim of many unusual and irrational thoughts, end quote. So he wrote in his suicide note that when this whole ordeal was over, that he wanted an autopsy to be performed to figure out what in the world was going on. And that's exactly what they did. They took his body to the coroner's office and they used a bone saw to drill off the top of the skull, and they lifted out his brain and carefully dissected it. And what they found was a tumor pressing against a part of his brain called the amygdala, which is a small region involved in fear and aggression. Now, how do we interpret this? Not everyone who gets a tumor pressing on their amygdala becomes a murderer. Nonetheless, did it have something to do with his crime? We'll return to this sort of question many times in future episodes because the answer isn't always obvious. After all, not everyone with a tumor in this area commits a horrific crime, so we have to look at the timeline of his behavioral changes and the presumed timeline of his tumor. And if they're well correlated, as they were in Whitman's case, this gives us more confidence that there was a connection. But for today's purposes, we can say that Whitman's tumor may well have had something to do with his drastic personality changes for the same reason that Phineas Gage's more obvious tamping rod had something to do with his personality changes. When your brain changes, so do you. So let's expose a few more examples like this, and then we're going to circle back around to the big picture question about how your actions result from your biology and how that affects the way we think about culpability in the legal system. This next case was reported in the medical literature. It was a 40-year-old man who was married. He had a normal sexual appetite, and then he started developing an interest in pedophilia. He started collecting child pornography, and then he tried to touch his prepubescent stepdaughter who lived with him and his wife. And at that point, his wife had him arrested. So while he was in jail awaiting sentencing, he started complaining of these terrible headaches, and they were getting worse and worse. So he was eventually taken to the doctor, and a brain scan was done. And what they discovered was a massive tumor in his frontal lobes, about the size of a golf ball. So he underwent an emergency neurosurgery, and they cut the tumor out. And his sexual appetites returned completely to normal. He no longer had any pedophilic urges. Now, the story has an important postscript because his wife took him back and everything was fine. But then about 6 months later, he started developing an interest in pedophilia again. So this time, instead of taking him to the police, his wife took him back to his neurosurgeon. And it was discovered that a part of his tumor had been missed in the surgery, and the tumor was now regrowing. So they resected the tumor a second time, and his sexual behavior returned to normal again. The lesson from the sudden pedophile is the same lesson that we can take from Phineas Gage and from Charles Whitman. When your biology changes, that can change your decision-making in quite dramatic ways. And the thing we're going to return to that's important is that he didn't choose to have a brain tumor, just like Whitman didn't, just like Phineas Gage didn't choose to have the tamping rod through his head. Now, what we covered in the last episode is that when it comes to things like your instincts or what you find beautiful or who you're attracted to or your decisions in life, these things are all driven by automatic circuitry in your brain. It's not about the conscious you. It's about your unconscious brain, to which you mostly don't have any access or acquaintance. So the notion of free will, we called that into question last time. Enough of our drives are so inaccessible that free will may not exist, or if it exists, it might be a small player in the system. Now, the question of free will matters quite a bit when we turn to culpability. When a criminal stands in front of the judge's bench, having recently committed a crime, the legal system wants to know whether he is blameworthy. After all, whether he's fundamentally responsible for his actions navigates the way that we punish. For example, you might punish your child if she writes with a crayon on the wall, but you wouldn't punish her if she did the same thing while sleepwalking. But why not? She's the same child with the same brain in both cases, right? The difference lies in your intuitions about free will. In one case, if she's awake, she has it. In the other case, when she's asleep, she doesn't. In one case, she's choosing to act mischievously. In the other, she's an unconscious automaton. So you assign culpability in the first case and not in the second. And the legal system shares your intuition. Responsibility for your actions parallels your volitional control. If someone commits a murder while awake, he hangs. If he does so while he's sleepwalking, which has happened many times, and I'll cover this in a future episode, then he's acquitted. Similarly, if you hit someone in the face, the law cares whether you were being aggressive or you have hemiballismus, which is a disorder in which your limbs can flail wildly without warning. If you crash your car into a roadside fruit stand, the law cares whether you were driving like a maniac or instead you were the victim of a heart attack. All these distinctions pivot on the assumption that we possess free will. But do we? Don't we? Science can't yet figure out a way to say, yes, we have it. Our intuition has a hard time saying, no, we don't have it. But what I covered in the previous episode is that if we have any free will at all, it is a bit player, because most of what we do unconsciously. So the question of whether we have free will or not is a tough scientific problem. But I propose that the answer to the question of free will doesn't matter for the purposes of social policy. And here's why. In the legal system, there's a defense known as an automatism. So what's an automatism? It's something that I have no conscious control over. So let's say I have that disorder that causes me to fling my arm out, hemiballismus, and I have no conscious input into this. It just happens. So one day I fling my arm out and I hit someone and they fall off a cliff to their death. From the point of view of the legal system, I'm not culpable for their death because it was an automatism. The conscious me was not involved. I didn't have any ill intention behind the act, or what the legal system calls mens rea, which is Latin for guilty mind. And this kind of thing comes up all the time in the courtroom. Let's say a person is driving a car and has an epileptic seizure, and that causes her to steer her car into a crowd of pedestrians. The automatism defense is used when a lawyer says, look, that act was due to a biological process over which the defendant had no control. In other words, there was a guilty act, but there was not a guilty mind behind it. Okay, but wait a minute. Based on everything we've been talking about, don't these kind of biological processes describe most or possibly all of what is going on in our brains? Given the steering power of our genetics, of our childhood experiences, of environmental toxins, of hormones, neurotransmitters, all the details of our neurocircuitry, enough of our decisions are beyond our explicit control that we are arguably not the ones in charge. So in my book Incognito, I proposed what I call the principle of sufficient automatism. And this arises simply from understanding that free will, if it exists, is only a small factor riding on top of enormous automated machinery. So small that we might be able to think about bad decision-making in the same way we think about other physical processes like diabetes or lung disease. The principle of sufficient automatism says that the answer to the free will question simply doesn't matter. To put this another way, Phineas Gage or Charles Whitman or the sudden pedophile all share the common upshot that actions can't be considered separately from the biology of the actors. Free will is not as simple as we intuit, and our confusion about it suggests that we cannot meaningfully use it as the basis of punishment decisions. Now, before I move on to the heart of the argument, I need to put to rest the concern that if we look for biological explanations about what's going on with people who commit crimes, that's going to lead to freeing criminals on the grounds that nothing is their fault. Will we still punish criminals? Yes. Letting criminals go wander the streets is not the goal of improved understanding. Biological explanation does not equal exculpation, which is letting people off the hook. Societies will always need to get bad actors off the streets. We will not abandon punishment, but we can refine the way we punish. See, in the current system, we use incarceration as a one-size-fits-all solution. As a result, America leads the world in the percentage of our population behind bars. Not everyone knows this, but we imprison more of our population than any country in the world. Look it up if you don't believe it. Now, aside from any moral stance you might have on this, it's a problem because prison is provably criminogenic, which means that it leads to more crime. That's because when you put someone in a prison, you break their social circles and you break their employment opportunities. And presumably you introduce them to new social circles and new employment opportunities. As a result, prison becomes a revolving door. Now, this is generally something that people have an intuition about. But what a lot of people don't realize is the estimate that 30% of the prison population has some form of mental illness. Jail has become our de facto mental health care system. In America, we used to have mental institutions, but these were all shut down in the 1960s in a process called deinstitutionalization, and the whole population flowed from there into the prison system. Now, we could reasonably have a discussion about the morality of this situation, but I just want to make a practical point that this is not a cost-effective solution to dealing with mental illness in our society because it has little to no utility in solving the problem. And here's another issue. Our prisons are stuffed with people who have drug addictions. This began when Nixon declared the war on drugs, and since that time, our prison population has gone up 8-fold. This is not the right place for us to be putting people with addiction problems. I'm not saying this is a morality play. The issue is that prison doesn't solve the problem. Addiction is a biological issue. You can't incarcerate someone and expect they're going to forget their addiction. And also there's an active drug trade in prison systems. So all this points to developing a better understanding of what's happening in brains so that we can route people through the system in a more tailored fashion. Now, I want to hit this point again. Would biological explanation equal exculpation? No. Better insight would lead us to be able to do many things. The first is rational sentencing. We don't have to build a legal system with an emphasis on how much we punish, but instead on how to best route individuals through the system. This doesn't let people off the hook who have committed a crime because we still need to keep our streets safe, but it does allow us to abandon the notion that all brains are the same and everyone should get the same mandated sentence, like 5 years for this crime. You can have lots of brains in front of a judge's bench for the exact same crime, but this one is there because he has schizophrenia, and this one is a psychopath, and this one over here is tweaked out on drugs, and this one has a brain tumor, and so on. Not all brains are the same, and people can be sentenced on more individualized grounds. And one of the key components of this is the second thing that we could have better insight on: customized rehabilitation. Instead of imagining that jail is the one-size-fits-all solution, we are increasingly getting more insight into what can be done for things like drug addiction, which I'll come back to. And the third thing is realistic incentive structuring, including deterrence and what kinds of punishments actually work for which kinds of people and which ones are a waste of time that only satisfy our bloodlust but are ineffective at the societal level. Because the fact is that brains are different, and we talk about things like tailored education. Why not talk about tailored social policy? So there's a real need for understanding what is happening inside different heads. It doesn't make sense for us to pretend that everyone is just like us or just like each other on the inside. And to help us think about this, here's an excerpt from Charles Whitman's suicide note. He said, quote, "If my life insurance policy is valid, please pay off my debts. Donate the rest anonymously to a mental health foundation. Maybe research can prevent further tragedies of this type," unquote. So some years ago, these considerations inspired me to start the Center for Science and Law, which brings together scientists and attorneys and policymakers to understand how science can refine our legal system. We tackle things like how neuroscience matters for a rational drug policy or a better understanding of the insanity defense. or how to think about sentencing in juveniles, like what happens when someone commits a terrible crime, but they're 16 years old, and issues like eyewitness testimony, and even the brain of the juror. I'm going to drop several episodes on these topics in the coming months. But for now, I want to emphasize the big picture issue, and that is what we understand and how we can move the science forward. So we know that the details of the brain map onto behavior, but it's an extraordinarily complex system, one of such complexity with its billions of neurons and trillions of connections that it bankrupts our ability to understand it. So how do we go about trying to understand the brain of someone who has committed a crime? So let's start by acknowledging that when big crimes happen, it's often the case that we don't even have a brain to examine. Lots of times, a person will commit a mass shooting and then shoot themselves in the head, which renders their brain unexaminable. Or take Adam Lanza, the shooter at Sandy Hook Elementary. I remember seeing on the news that he had smashed his computer and hard drive before committing the crime. But that struck me as the least of our problems because Lanza had committed suicide within 15 minutes of the 911 call by shooting himself in the head, meaning that it wasn't just his hard drive that you couldn't get data from, but his brain as well. So the point is that we couldn't even take a swing at seeing if there was something wrong with his brain, like a tumor or a malformation that he was born with, or a stroke. And this situation is actually surprisingly common. Take the guy Joe Stack, who was mad about his taxes, and so he flew his small plane into the IRS office building. Everyone hypothesized about what had gone wrong with Stack based on his suicide note and his behaviors leading up to the attack. But was there anything pathological going on in his brain? We'll never know because it was destroyed in the crash. But what happens when we do have a brain to look at? What can we conclude? How well can we understand the details of a person's behavior when we look at their brain? Well, you've probably seen the wonderful pictures from brain imaging. There's a technology called functional magnetic resonance imaging, or fMRI. And this is a technique where someone lies down in a big cylinder and we can image activity in the brain tissue through the skull. It's quite miraculous and beautiful, and I've spent a good chunk of my career publishing papers in which we use fMRI. But I want to emphasize that even this, our best technology for imaging human brains, is very limited. We're not directly imaging the activity in the brain, but instead the blood flow, the ratio of oxygenated to deoxygenated blood. And so where the blood flow goes, that tells us that some activity was just happening there a few seconds ago. And it's not precise at the level of individual neurons and their tens to hundreds of electrical spikes per second, but instead, all we can get from it is that there was something happening in this cluster of tens of millions of neurons at the scale of seconds. So here's an analogy to think about fMRI. Imagine that you're in a space shuttle and you're looking down on the United States. You could see big events like a major forest fire in California, but you wouldn't be able to see how the economy is going, or what fashions people are now wearing, or who won the World Cup. You could only see really big changes. And that's the same with brain imaging. We're only able to see really obvious things going on. And that puts us in a funny situation because it puts pressure on scientists and lawyers and courts to say more than they're able to. Everyone wants to see a brain scan and see if there's something different going on with this guy. But our technology, most of the time, doesn't allow us to do that. Now, part of the problem is that the media around us, they constantly suggest that we can look at a brain scan and say something clear about someone's behavior. So I've made a little collection of Time magazine covers that drive me insane. For example, one cover shows a brain scan image with fancy colors, and the title reads, "What makes us good or evil?" And there's a little picture of Gandhi with an arrow to a small spot in the brain, and another picture of Adolf Hitler with an arrow to another spot. And the concern is that this gives the general population a kind of erroneous thinking that we should be able to run a brain scan and just see whether someone is good or evil. But that's impossible for technical reasons, and also because good and evil are not straightforward concepts. You can't look at activity in a particular part of the brain and say, yes, that person is evil. Friedrich Nietzsche wrote about this over 100 years ago in his book, Beyond Good and Evil, where he pointed out that the concepts of what is good and what is evil, these are historically defined, and they're different in different cultures and different time periods, and they can be quite locally defined, and they can be user defined. As you know, when you get into a political argument with a family member or a coworker, and you think that something is evil that they don't, or they think something is evil that you don't. Although we can typically agree on things at the extremes, there's no single right answer to what constitutes good and evil for almost everything in the middle. So, importantly, the relationship between a person's brain and their behavior can generally be totally opaque, totally impossible to read, as in, perhaps you have a tumor in part of your brain, or you've had traumatic brain injury or a stroke that damaged part of the tissue in your brain. But is that actually the reason you committed a crime? Or did you do it because you would have done it anyway? Take the movie House of Gucci. This is about Patricia Reggiani, played by Lady Gaga, who marries Maurizio Gucci, who is the heir to the Gucci fashion fortune. So she's 22, she meets Maurizio Gucci at a party. 2 years later, they marry, they have 2 daughters. It seems to everyone around them like it's a fairy tale. But a few years later, Maurizio separates from her so that he can date a model. And things turn really sour with Patricia. She starts stalking him. She plants spies around him. She keeps calling and threatening to kill him. And then one day, as Maurizio Gucci is walking through the lobby of an office building, he gets shot by a hitman and dies. And the day he's killed, Patricia writes paradise in her diary. Now, given her hatred of Maurizio, Patricia immediately becomes a suspect, and soon enough, the evidence clearly points to her as the hand behind the hitman. And it goes to court, and Reggiani is charged with murder along with her psychic and the hitman and the getaway car driver, and she gets sentenced to 26 years in San Vittore prison for having ordered the killing. So this is a wild, true story, and it made a good movie. But the most fascinating part picks up where the movie ends. So the real life twist is that after she went to prison, Patricia's legal team campaigned for a retrial. They argued that Patricia was not in control of her mental faculties during the murder. Why? Because she had undergone surgery to remove a brain tumor some years before. And they argued this surgery had affected her ability to be in command of her mental faculties. It wasn't precisely her fault, they argued. It was the fault of the tumor and the brain surgery. Now, how should a court assess this? After all, she famously hated him, and she always talked about how unhappy she was and how much she wanted to kill him. So her argument about the brain surgery only partially convinced the court. It didn't change much of anything materially. So what I want to illustrate here is the complexity of looking for easy answers. Did her small tumor that was removed have something to do with her crime, or was it totally incidental to the crime? In other words, having nothing to do with it. A biological problem doesn't necessarily tell you a clear story about the interpretation of a crime. And this difficulty in interpretation comes up in all sorts of guises in the courtroom. Take concussion or a traumatic brain injury. If someone robs a store, how do we know it had anything to do with the concussion? Maybe this was the kind of guy who was always headed for trouble anyway. Maybe he's been doing this kind of antisocial behavior since elementary school. Everyone knew this guy was trouble. And then 2 years ago, he hit his head hard, and everyone agrees that was a bad thing. But now his lawyer argues that his crime resulted from the traumatic brain injury. Maybe it's a slightly worse crime as a result, but maybe he's just graduating to the next level as a criminal. It's hard to know. And there's no brain scan that can magically tell you the answer, because his behavior also results from everything else in his life, his circumstances, his group of friends, all the details of his decision-making. So just knowing that someone had a brain injury tells us very little about the details of why they committed a crime. And the flip side is true too. Somebody might commit a horrific crime and their brain looks totally normal. So take the Las Vegas shooter, Stephen Paddock. In 2017, he smashed out the window of his hotel room at the Mandalay Bay, where he'd been stockpiling arms, and he started shooting at the people below at an outdoor concert, and he murdered 60 people, and he injured about 867 this way, in the deadliest mass shooting in the United States. So at the time, I wrote an article on CNN about what might be wrong with his brain, and I was careful to end it by saying, look, there might be nothing that's obviously wrong with his brain, so we might never have anything that we can conclude here. His brain was sent over here to Stanford to my neuropathology colleague in the medical school, who did an analysis and concluded nothing. He couldn't find anything that was obviously wrong with Paddock's brain. There was no giant tumor or giant stroke or neurodegenerative disorder or anything like that. So I've just told you a number of things, and I want to pull these all back together in the question of what does this mean for the notion of culpability? Well, there are several points of view we could take here. One view proposed by the neurophysiologist Wolf Singer goes like this. He says, quote, as long as we can't identify all the causes, which we cannot and probably never will be able to do, we should grant that for everybody, there is a neurobiological reason for being abnormal, end quote. In other words, in Singer's view, the act of committing a crime is all the evidence we need for a brain abnormality, whether or not we can see it, whether or not it's obvious. Some years ago, there was a biologist at the University of Alabama in Huntsville named Dr. Amy Bishop, and she was denied tenure, which means the university declined to give her a permanent position. And the next week, there was a routine faculty meeting in the biology department, and she stood up with a 9mm Ruger handgun and began shooting the other faculty members one by one in the head. So speaking to the media, Amy Bishop's defense attorney, Roy Miller, said, quote, I think the case speaks for itself. I think she's wacko, end quote. Now, this was her defense attorney. So this might not sound like a very good defense, but essentially her attorney was taking Wolf Singer's position that the act of committing the crime was all the evidence we need for a brain abnormality. And that's why he said the case speaks for itself. So I've planted a bunch of question marks here, and now I want to come back around to the main question. What does all this add up to for our notion of culpability? Well, think of culpability as lying on a spectrum, with Phineas Gage all the way at one end, where we say, look, it's not really your fault. And next to him, maybe the sudden pedophile with the brain tumor. We look at them and we say, you poor guys, you didn't choose that. You didn't ask to get a tamping rod through your head or to grow a prefrontal brain tumor. So any changes in personality or decision-making can't really be your fault. It's just a matter of your biology. Now, as we move along this line towards the center, we come to cases that clearly have to do with the brain, but they're not quite as easy to interpret. So in the last episode, I talked about Chris Benoit, the Worldwide Wrestling Federation champion, who conspired with his physician to take huge quantities of testosterone, and that sent him on roid rages, and he ended up killing his wife and his son. So that has to do with his biology, but maybe it's not so easy for us to say, well, it's not exactly your fault. Or we find Amy Bishop, the biologist who killed her colleagues, and we think something is wrong with her, but we can't quite identify what. And then at the far other end of the spectrum, we find your average criminal sitting in a jail cell. Nobody's studying his brain, and even if someone were, our current technology probably wouldn't be able to say much anyway. The overwhelming majority of lawbreakers are over on this side of the line. And even if we spent millions of dollars and did brain scans on all of them, almost all of them wouldn't have any obvious, measurable biological problems. And so as a result, the legal system thinks of them as freely choosing actors. This spectrum from Phineas Gage to the common criminal captures the common intuition that juries have regarding blameworthiness, where at one end we say it's not your fault, and at the other end we say it is your fault. But there's a deep problem with this intuition, which is that our technology draws a line on the spectrum, and on one side of this line we say, hey, we can measure something, so it's not your fault. And on the other side we say, look, we can't really measure anything and point to something, so we're going to say it is your fault. The problem is that technology will continue to improve. And as we grow better at measuring problems in the brain, the line that separates the not blameworthy side from the blameworthy side, it will continue to move, such that people who we now hold fully accountable for their crimes will someday be understood to have whatever the next level of technology is going to teach us. That, for example, they have Schmedley's disorder and couldn't control their behavior. Problems that are opaque to us today will open their flower petals to new techniques. And in 100 years, we're likely to find that many types of behavior have a basic biological explanation, as we've already found with schizophrenia or epilepsy or depression or mania and so on. In other words, today's neuroimaging is a crude technology. It's not able to explain the details of individual behavior. We can only detect large-scale problems. But within the coming decades, we will be able to detect patterns at unimaginably small levels of the microcircuitry that correlate with behavioral problems. And neuroscience will be better able to say why people are predisposed to act the way they do. And as we become more skilled at specifying how behavior results from the microscopic details of the brain, more defense lawyers will point to biological mitigators of guilt, and more juries will place defendants on the not blameworthy side of the line. Now, all of this puts us in a strange situation, because after all, a just legal system can't define culpability simply by the limitations of current technology. A legal system that declares a person culpable at the beginning of a decade and not culpable at the end is one in which culpability carries no clear meaning. The crux of the problem is that it no longer makes sense to ask, to what extent was this crime committed because of his biology, and to what extent was it committed because of him? Because there is no meaningful distinction between a person's biology and his decision-making. They are inseparable. A system of blameworthiness that depends on the technology of the day can't represent real justice. The whole notion of blameworthiness is a concept that demands the impossible task of untangling the hopelessly complex web of genetics and environment that constructs the trajectory of a human life. So, our current approach to punishment rests on a bedrock of personal volition and blame, but our modern understanding of the brain suggests a different approach. My suggestion for a number of years now has been that blameworthiness should be removed from the way we talk about things in the legal system. Blameworthiness is a concept that looks back and demands the impossible task of figuring out how a brain came into its current form. But instead of debating culpability, I suggest our effort should be to focus on what to do moving forward with an accused lawbreaker. The legal system has to become forward-looking, primarily because it can't continue much longer pretending that it can do otherwise. Because as we come to know more and more about the brain and science continues to complexify the question of culpability, our legal and social policy is going to have to shift to a different set of questions. How is this person likely to behave in the future? Are criminal actions likely to be repeated? Can this person be helped towards pro-social behavior? How can incentives be realistically structured to deter crime? The important change is going to be in the way we respond to the vast range of criminal acts. Consider as an example that the vast majority of known serial killers were abused as children. Does this make them less blameworthy? It's actually the wrong question to ask. The knowledge that they were abused encourages us to build social programs to prevent child abuse, but it does nothing to change the way that we deal with the particular murderer standing in front of the bench. We still need to keep him off the streets, irrespective of his past misfortunes. The child abuse can't serve as a reason to let him go. The judge has to keep society safe. So people who break social contracts need to be confined. But in this framework, the future is equally as important as the past. So deeper biological insight into behavior is going to give us a better understanding of recidivism, that is, recommitting of crime, and that gives us a way to base sentencing on the individual. Some people will need to be taken off the streets for a longer time, even a lifetime, because their likelihood of reoffense is high. Others, because of differences in neural constitution, are less likely to recidivate, and so they can be released sooner. Now, if this sounds strange, keep in mind that the law is already forward-looking in some respects. Think about a crime of passion versus a premeditated murder. You know, a woman murders her husband when she finds him in bed with a lover versus a woman who plots out and murders her husband for his life insurance. Courts tend to be more lenient on crimes of passion. Why? It's because those who commit a crime of passion are less likely to recidivate, to reoffend, than those who are premeditated, and their sentencing reflects that. And in the same way, most legal systems draw a bright line between criminal acts committed by people under 18, minors, and crimes by adults, and they punish adults much more harshly. The approach of putting this dividing line at your 18th birthday is arbitrary and not terribly specific, but the intuition behind it makes sense. Adolescents have fewer skills in decision-making and impulse control than adults do. A teenager's brain just isn't like an adult's brain. So lighter sentences are appropriate for those whose impulse control is likely to improve naturally as adolescence gives way to adulthood. So what would it look like if we could expand on these intuitions and elevate things into a more scientific approach to sentencing? In some cases, this is already happening. So take the sentencing of sex offenders. Some years ago, researchers asked psychiatrists and parole board members how likely specific sex offenders were to relapse when they were let out of prison. So both groups, the psychiatrists and the parole board members, had lots of experience with these particular sex offenders. So predicting who was getting on the right road and who was going to be coming back to prison seemed pretty straightforward. But surprisingly, these expert guesses showed almost no correlation with the actual outcomes. The experts had only slightly better accuracy at predicting than coin flippers. So this astounded the legal community. So the researchers tried something a little more like how life insurance companies do things. Using statistics, the researchers gathered a huge cloud of data from 23,000 sex offenders who had been released. They looked at whether the offender had unstable employment, had been sexually abused as a child, was addicted to drugs, showed remorse, had deviant sexual interests, and on and on and on. The researchers then tracked them for 5 years after release to see who wound up back in prison. And at the end of the study, they computed which factors best explained the reoffense rates. And from this, they were able to build statistical models, also called actuarial tables, to use in sentencing. So when researchers compared the predictive power of the actuarial approach with that of the psychiatrists and parole boards, there was no contest. It turns out, perhaps not surprisingly, that numbers beat intuition. So in courtrooms across the nation, these actuarial tests are now used in pre-sentencing to dial the length of prison terms. Not everyone is getting exactly the same length of sentencing. As a side note, the way to make a system like this immune to government abuse is to make the data and equations that compose the sentencing guidelines transparent and available online for anyone to verify. Now, I need to make it clear that we're never going to know with certainty what someone's going to do when they get released from prison, because real life is complicated and crime often depends on the context that someone finds themselves in. And an approach like this offers individualized tailoring in place of the blunt guidelines that the legal system typically employs, where everyone gets the same sentence. And beyond customized sentencing, a forward-thinking legal system informed by scientific insights is going to allow us to stop treating prison as the one-size-fits-all solution. Now, to be clear, I'm not opposed to incarceration. It has several purposes, including removing dangerous people from the streets, and just the prospect of going to jail deters some amount of would-be crimes. But deterrence only works for certain brains in the population. I mentioned that prisons have become our de facto mental health care institutions, and inflicting punishment on the mentally ill usually has little to no influence on their future behavior. So an encouraging trend is the establishment of mental health courts around the nation. These are specialized courts where you have judges and juries with expertise in mental illness. And people with mental illness can be helped while being confined in a tailored environment. There are many cities that are moving to this sort of specialized court system for reasons of justice and cost effectiveness and general efficacy. And similarly, there are lots of jurisdictions that are opening specialized drug courts and developing alternative sentences. They've realized that prisons are not that useful for solving addictions as compared to, let's say, a meaningful drug rehabilitation program. And this is the other big benefit of a forward-looking legal system, is the ability to parlay biological understanding into customized rehab. Viewing criminal behavior the way that we understand other medical conditions like epilepsy or schizophrenia or depression, conditions that now allow the seeking and giving of help. And so we can seek rehabilitative strategies for people in all sorts of circumstances instead of imagining that incarceration is the optimal solution. So let's wrap up. Along any axis that we use to measure human beings, we find a wide-ranging distribution, whether in empathy or intelligence or impulse control or aggression. People don't have the same brains. The variation between people, the fact that we're not all alike, gives rise to a wonderfully diverse society. But it's a source of trouble for the legal system, because that is largely built on the premise that everyone is the same. The idea of human equality suggests that everyone is equally capable of controlling his impulses, or making good decisions, or comprehending consequences. And while that is a very charitable idea, a real look at the data suggests otherwise. As brain science improves, we're going to better understand the ways in which people exist along these spectrums rather than all in one box or even in a few simple categories. And once we take on board that people are meaningfully different, we'll be better able to tailor sentencing and rehabilitation for the individual rather than maintain the pretense that all brains are going to respond optimally to identical prison sentences. Neuroscience is beginning to touch on questions that were once only in the domain of philosophers and psychologists, questions about how people make decisions and the degree to which those decisions are truly free. These aren't idle questions. Ultimately, they're going to shape the future of legal theory and create a more biologically informed system of justice. If you're interested in learning more, check out scilaw.org, SCILAW.org. That's my nonprofit that works at the intersection of the brain and the law. And you can find lots of further readings at eagleman.com/podcast. Until then, this is David Eagleman signing off from the inner cosmos.